Writing code is writing a precise set of instructions a computer or device can understand. It's explaining exactly what you want your computer to do at any given moment. Computers need to know exactly how to react to things like the clicking of a mouse or the pushing of a button. And whatever happens, ultimately is happening because of lines of code written by a human programmer. Just about anything with a plug or battery uses code. It's keeping our airplanes in the air. It's allowing you to swipe a credit card. And the computer doesn't know what to do in any given situation. It has to be taught everything. So you can think of a computer programmer explaining to a computer what we want it to do as like trying to give someone directions for how to drive somewhere when they don't even know what a car is. So you can see what kind of complications you'd run into. You'd have to not only tell them how to get to where they're going, but you'd also have to give them contingency plans for things like what if there's a traffic jam, or what if a truck breaks down in the turn lane, and you'd even need to explain precisely how the steering wheel or gas pedal works. So that's kind of like a computer programmer writing code for a computer. They have to basically teach it everything every time. To understand that communication and how this process even started, you have to go back to the Industrial Revolution, where the first computer program was invented in 1801 by a guy named Joseph Jacquard. He developed a system of weaving instructions, or code, for his sewing looms that could be stored on cards with holes. And there was a mechanism that would go along the card and try to push a pin through. And so either the pin would go through or it wouldn't. It's binary. It's either it does or it doesn't. It's a 1 or it's a 0. And so if the pin goes through the hole, it would allow a rod attached to it to lift, which lifts the string and lifts the associated thread. And if the pin does not go through a hole, the pin doesn't move and the thread doesn't move. So essentially, the card would hold a preset pattern that is read by the loom and serves as a guide, giving the direction to the threads one at a time. And with this contraption, you could create very fancy pieces of weaving. And this idea of there being recorded information read by a machine was quickly borrowed to be applied to mathematical computation. Charles Babbage invented the analytical engine in 1837, and it was basically a calculating machine. Eventually, transistors are invented, which replace punch cards as a way of transferring data, and nowadays we use computers that have billions and billions of transistors, but still carrying that same basic idea of on and off to carry data. As a way of harnessing these various combinations of transistors, we use code. Computer programmers use different languages, whether it's Python for gaming, Java for desktop applications, or Objective-C for an iPhone app. A computer program is only a text file following those rules, and it's eventually translated into something the computer can understand. Just like the pins on Jacquard's loom, a computer can only understand two things. Think of 1 and 0 as the alphabet of a computer. It's like, if you look at the alphabet of the English language, there's only 26 letters, and by themselves, they're meaningless. But when you combine them into different ways, you get the Great Gatsby, or Romeo and Juliet. In the same way, billions of different combinations of 1s and 0s have the potential to give us Microsoft Word or iTunes. And the process goes like this. On the top level, you have a human writing code for a specific computer language, and after this, the code is translated or compiled into a low-level language by a tool called a compiler, and finally, the code is translated into binary or machine language by an assembler. So because we have a way of translating human orders in the form of code into 1s and 0s that a computer can understand, after that, it's really just a matter of what you want the computer to do. And it's like being a chef writing a recipe, because both chefs writing recipes and computer programmers writing code both have the ability to create something awesome using the resources and tools available.